Okay, we're going to wrap up section 3.1 today. On the previous day of notes, we talked about looking at a relation, a series of points, and determining domain and range, which I'm going to go ahead and kind of go back to real quick. We look at this set of points right here, this four set of points. Domain is all of our x values, so the domain for this set of points would be 2, 3, 5, and 1, and the range, the y values, would be 3, 4, 6, and 1. So that's just a little bit of a review from what we did on the first set of notes. Now what we're going to be focused on is whether or not something is a function or not. Now keep in mind, when we're talking about trying to determine if something is a function or not, there's one main goal. Okay? All functions have one rule. No x's repeat. Okay? We can't have the same x value come up several times and they set for a function. Because the easiest way we can determine that, I'm going to show when we go over the graphs. Okay? Because if you'll notice here, besides the fact that I miswrote some of these examples, we have an example that we haven't seen yet with the two circles with domain and range. We're going to have examples of graphs, and we're going to have examples of sets of points and tables. And then I'm actually going to work completely backwards today because these, I think, are going to help us with comprehension off the bat. Now, once again, we know this is x and the y's, domain and range. We want to determine if this set of four points is a function. All we have to focus on are the x values. So we have 2, 3, 5, and 1. We notice that none of those x values repeat. And since none of those x values repeat, we have a function. Okay? That would be a function. Looking at this bottom one, we have 1, 5, 5, and 9. Now, we had 5s repeat right there. Okay? Since we had 5s repeat right there, we don't have a function for this second set. Because we can't have, when we plug in 5 to something, we can't have it equal 1 and 6 at the same time. Okay? It has to be one or the other. All right? Now, if we're looking at two tables, reminder, this is still basically sets a series of points. Like, for instance, we have the point 1, 6, 2, 6, 3, 4, negative 1, 6, and so on and so forth. Okay? And just as before, if we're trying to determine if this is a function or not, we only have to focus on the domain, the x's. Since all these x's are different, 1, 2, and 3, we have a function. All right? Now, students in one of my classes said, now wait a minute here, the y's repeated, so we would not have a function in this case. Okay? Now keep in mind, we don't focus on the y's, we don't focus on the range. All of the y values or the range values could all be the same number and it could still be a function. The only rule we have is none of these x's can repeat, which we do see happen in this bottom example. We have two 5s that repeat for the x's. Just like we had over here, we can't plug in 5 and get negative 1 and 0. We can't plug in something and get two different values. Okay? So once again, this is an example of not a function. All right? Once again, these are the ones that are a little bit easier to read. The ones that are a little bit harder to read would be examples where we have the graphs. Okay? So I have these two graphs, and what we actually use is something called the vertical line test, sometimes abbreviated as VLT. And what that means is I should be able to take a piece of paper or a note card or just be able to visually see it. I should not be able to draw a vertical line anywhere on this grid and end up with two or more points on a given line. Okay? Two or more points on a given line. So for this first graph here, this first point's at negative 10, 0. If I were to draw a vertical line right there, or if I use my piece of paper, I only see one point on that line. Okay? 1 point of my graph that hits that line. So that works. I would just simply move to the next point. See, once again, there's only 1 point. And if I continue through the rest of the graph, I will always, every time I try to draw a vertical line through 1 point, that is the only point my line would hit. So since we don't have any places where we have 2 points on one vertical line here, this is a function. Now, looking at the second graph, okay, if I did that same process, we would have a negative 10, okay? I move on to negative 8. I notice that we have 2 points at negative 8. One negative 8 equals 0, the other negative 8 equals 3, okay? Now, once again, if we just look at those as 2 points, that's negative 8, 0, negative 8, 3. If we look at these as coordinate points, look, once again, we have x's repeating. So that's why we don't have a function in this case, all right? We can't have two values equal, we can't have one x value equal two different things. Think about it this way. If you worked and you made $20 an hour, okay, and you work for 5 hours, okay, I can't have 2 points of the x equal two different things, okay? For instance, if you work 5 hours, you get $20 an hour. If I plug 5 into that equation, I should end up with $100, okay? I can't do 5 times 20, okay, that would be 5 times 20 there, you get 100, but also plug this in and get like 20 bucks, okay? That's what this is meaning, because this down here is basically saying, if I work 5 hours, I could get 100 bucks, or I can work 5 hours and get 20 bucks, okay? It has to be one or the other. This makes no sense to have 2 points where you get two different values like that, okay? And hopefully we're reaching for that one right there. Now, for the last examples we have here, we have these circles, which D and R are above each circle. As you can probably guess, they stand for the domain and range, which once again, the domain is all the x values, the range is all of the y values. Once again, it doesn't matter about the y's or the range at all here, okay? We are focused mainly on the domain. Now, you see the bunch of lines that are up here as soon as it focuses, and these are still the coordinate points. For instance, 2 connects with the -4, so that means my first coordinate point I have is 2, -4. And I can continue this to the rest of them. 3, 8, 4, 6, 5, 8, 6, 5, okay? That's how I can list all those coordinate points. But mainly what we need to focus on is if we look at the domain and we see that there is only one line coming off of every x, we are going to end up with a function in this case. Because if there's only one line on each of these, that means none of them are repeating. If we look at the second one right here, 4 has one line, 3 has one line, 2 has one line, but then the first one here has two values, one -6 and one 4. That means we have repeating x's, and we can't have repeating x's happen in a function, so this one would not be a function. Now the last one here, we have 3 values of x's going to one y, and the 3 values of x's going to a different y. It doesn't matter, they all could be going to the same y as long as each of these points have one line, we are going to have a function, okay? Remember, we're only looking at the x's when it comes to determining if something's a function or not, okay? Once again, if we're given graphs like these, we just want to make sure one line per number in this domain circle. If we're looking at graphs, we can use the vertical line test to determine if we have more than one point on a given vertical line. And if we're looking at points, we're basically just looking for the first column or the first number in parentheses and seeing if we have any repeaters. If we have repeaters, or if we have 2 points on one line, or if we have more than one line coming off of a number, it's not a function. Otherwise, we do have functions. All right, that will complete this short coverage of finishing up section 3.1 here. Make sure we're working on our assignment for this section. And as always, if you have any questions, send me an email.